Hi, this is Craig with Games with Authentic Battle Damage. Today we're just going to finish out our rock, paper, scissors game and get it working in the state that we want it to work to be a complete game. If you want to check out how we got to this point, please look at the last video. I'll leave a link right here and you can see how we got to here. So basically what we're going to do now is we're going to expand on our win table. What we did in the last video is we created a win table to represent our win condition, and we didn't completely finish it. We just created a test to make sure that it worked. So this is what it would look like if we finished it out. Okay, so this is how the final thing would look. But let's just simplify this a little bit more. Let's make it so I want to make it so that it's more readable for me and we don't have all of these lines of code. One of the things that we can do is when we create an array, we can actually fill the data at the time that we create it. So by using brackets, we can then create the structure that will be within this win table. And the way that we do this is this bracket is the overall win table. And then what we would do is then create three different, so like for example, it would be like an array within an array. So this is basically, look at this as like an array. And then we have, here we have an array. Here we have an, whoops, we don't want that. Here we have an array, and here we have an array. 3. So, and then inside here, there would be, 3 values. All right. So just to understand this, so we've got 3. This 3 right here represents 1, 2, 3. And then this 3 represents inside 1, 2, 3. So that's how these things map. Okay, then what we can do is we can then get rid of all of this. And now look at it this way. So our first element here, this right here, is element 0 of our first one. So this one is 0, this one is 1, and this is 2. So let's put these on different lines. All right, so this is 0, 1, 2. And then inside here, this is 0, 1, 2. So it's just like what we had before. In our other table, we had each of these things defined so that they made sense. So basically this 0 is rock. This one is paper, because that equals, up here you can see paper equals 1 and scissors equals 2. So this one is scissors. And then inside here, this is rock. This is paper. And this is scissors. So, rock to rock would be a draw. Rock to paper would be a lose. And rock to scissors would be a win. This might look confusing because I'm putting in these comments, but it's just to explain how what the structure really looks like. So now paper with paper here, we can do the same thing. We can take this and go like this, and then same thing here. So so paper to rock is a win. Paper to paper, oops, is a draw. Paper to scissors is a lose. Now scissors to rock is a lose, and scissors to paper is a win, and scissors to scissors is a draw. There. All right. So now because we're not using these, we can just comment them out. And then down here, we will start to do the actual game. So the first thing we're going to need to do is we're going to need to get the player's choice. So let's put our game into a loop. I'm going to choose the do while loop. And let's just have, we'll have an answer for if you want to continue the game. If answer equals yes. Okay, and then let's create our answer string. There. And then this will be a part of the game. So we'll put this down here, be evaluated more towards the end. All right. And then let's do some introduction to our game. So we'll do console.writeLine rock. Then choose your weapon. Computer has already chosen. So let's get the computer to choose. So we'll do int computer choice equals, let's make a random object. Random is a part of the system.random, but because we are using system up here, we don't have to specify that. So we'll do random rand equals new random. And then we'll do rand.next. And let's think about like what numbers do we need. He's going to be choosing either rock, paper, or scissors, which is going to be 0 to 2. So we'll want to have it start at 0, and we'll go to 3 because that is the inclusive number. So it's going to pick a value between 1 and 2. So this is the end of what the random's going to choose. All right, so we've got our random choice. And then here, why don't we show them what they can choose. So now the player will need to make their choice. So 1, the player's going to be choosing their weapon, rock. All right. And then here we can have the player choice. And when we get the player choice, we're going to be getting it from the console. So we'll do a read line. Now, read line is going to return a string. So this isn't going to work. So we're going to need to convert it. So let's use the system.convert. Yeah, but because we're using system, we don't need to. Convert to int 32, and then we'll just wrap our read line inside of this function. Convert to int 32. So that's going to take the string and try to convert it. Now, we're not going to be dealing with errors at this point, but really we need to capture an error here, because if you put in something that isn't a valid int, it's going to blow up. So, all right. So now we've got if win table player choice equals draw. It's a draw. Let's do some scoring. We want to save some score, so let's do player score equals 0. Computer score equals 0. And then, now notice too, we did this outside of the loop because we don't want to reset these values each time. We want to save them. Draw score equals 0. So how many draws we get. And then here, for the draw, we'll just draw score plus 1. Now we'll just do the same thing here for... Boy, I didn't want to do that. All right, so it's a lose, so that means the computer won. 1 computer score. And player score. There. Now, it's great that we're keeping score, but we'll need to print that out somewhere. So let's put that right here. We're going to have to see how this looks. So player score. All right. Okay, let's see how this looks. Is there anything? Yeah, let's take a look. Okay, here we go. Rock, paper, scissors. Choose your weapon. Computer is already chosen. Player score 0, 0, 0. All right, I'm going to choose a rock. It's a draw. And then we see here that the computer, or we can see that it just ended. That's because we set up this answer stuff, but we're not asking them to answer. So let's do that now. So console.writeLine, would you like to play again? Then we will get the answer here, and we'll do just a console.readLine. And you know what? Obviously, if we're going to force them, answer. Okay, let me build this for a second because I can see it's complaining. We have our answer out here. Oh, haha. Unexpected symbol answer. Whenever you get an error, one of the first things you want to do is look at the last line and make sure you didn't miss a semicolon. That's a good habit to get into. All right, there we go. Anyway, I don't want to have to make them type yes every time. And here we're giving them a prompt. We're like saying, you know, yes or no. But really we only care about yes, because if it's no, then the program will end. So let's do answer. And then also if they give us an uppercase Y, let's just make everything lowercase. So on the string, there's a method called toLower. And that way we can test. If they give us an uppercase 1, we'll just turn it lowercase and then we'll test it. But if they give us yes also. So, okay, answer.toLower equals Y, or answer.toLower equals yes. There. That way we cover both. So this is a logical statement. It's an OR statement. And what it does is it'll evaluate this one. And if this one is false, it will evaluate this one. Now with OR statements, both should get evaluated. All right, so let's play this again. Okay, let's do scissors. Index out of range. Okay, so let's take a look at exactly how is it out of range. We've got here player choice and computer choice. And player choice we have 3. Computer choice is 1. So we told our computer to do between 0 and 2, which is within the range of our rock, paper, and scissors. But you'll notice here, in our player choice, I did scissors, so it came in as a 3, and there is no 3. You'll see here, it only goes up to 2. So here is element 0, element 1, and element 2. And then here would be 3. If we added another one like this would be our third set, but it's not there. So it is giving us an index out of range exception. So here's what we need to do. What we need to do is we need to make sure that whenever we get a player choice that we just -1 from it. That way if they give us 0, if they give us 1, it'll be 0, 2 it'll be 1, and 3 will be 2. So we can do player choice equals player choice -1. All right, let's try this again. Let's do 3. Just I accidentally hit something, so that was the error I was talking about earlier. All right, let's try this again. Let's do 3 again to test. There, it worked. Now this time we got a win. Would you like to play again? Yes. Now, you see how it's printing down here? I don't really like that. So let's add a clear. Console.clear. There. All right, this time let's choose rock. Oh, I won. That's awesome. Okay. Then I'm going to choose paper. Man, killing. 3. Oh, I lost. So now we see that I've got 2, the computer's got 1, and that there are currently no draws. So it looks like our program is working. Yeah, let's call it a day here. So basically what we have is we have a console program that does rock, paper, scissors. And we basically have made it so that, you know, we're not using any functions, any methods. We're just doing it all within one main method. In the next lesson, I'm going to be taking some of these things and we're going to be turning them into methods as a way to make the program clearer and control the flow of the game. Doing it on a very simple game like this allows you to understand the C# programming language and how and why you use methods and functions to simplify your program. Because again, going back to our principles, complexity is the enemy. You want to try to do it the most simple way possible for you. So that's what I'm trying to do here. Creating representations for the win cases, representations for the rocks and papers, and then creating a table that represents those things. And then here is our logic where we're printing out, everything and seeing whether or not they won or lost. And yeah, so complexity is the enemy. And when we work on functions next, we're going to talk about ambiguity in the black box and how basically there's only so much stuff you can keep in your head. So we'll be talking about that in the next lesson. And making it so that you don't have to keep everything in your head is going to make you a better programmer. So thanks for watching. Please subscribe if you like this and you want to see more. Like the video if you like what you've seen, and let me know in the comments. Thanks for watching.